Okay. So students, let's start today's class. So we'll discuss the graphical method to calculate the equations of motion. Please check your notes, students, and let me know if I already taught you. Then we'll move forward in our syllabus. Please check with your notes. Have I already taught you the graphical method of derivation of the three equations of motion?
No, sir, I haven't done it.
You didn't?
No, sir, I
Okay.
haven't done
Okay.
it.
Okay. Okay. So let me teach. I think I didn't teach you
Yes.
that.
So we are done through calculus method.
So the graphical methods, first of all, the velocity time graph. So 1 minute here. So, students, we will draw the two axes along the vertical direction. That this is y-axis, and this is x-axis along the horizontal direction. And the quantity which we represent along the x-axis and along the y-axis will be zero at this point. This is called origin. Suppose that these are the velocity. This is initial velocity of an object, and this is the final velocity of an object. Suppose that object is continually moving with some velocity, and the velocity is constant. In that case, the constant velocity is represented by a straight line. So, student, if the object is moving with a constant velocity, then the velocity is represented by this straight line. So that is also called the uniform motion. So when an object has uniform motion, students, this is very important concept, and you will face many questions from this portion. So please, if some of you are not able to understand any point, you can ask. I will explain it. Okay. So the motion, uniform motion, it moves with uniform velocity. What is the uniform motion? The object moves with the uniform velocity. The object will move with the uniform velocity, means the magnitude of velocity is fixed. It is having fixed magnitude of velocity. Then,
Yes, sir.
yes, the
Sir,
velocity time graph. First, let me complete. The velocity time graph will be a straight line. So for an object which is moving with uniform velocity, suppose that this is the motion and the object started from this position and stopped at this position. And what about the velocity? It started with the velocity as 20 meter per second and ended with the same velocity. So velocity is constant. This is called constant velocity, constant or uniform velocity. Now ask, who was asking something?
yes, sir. Sir, we have written that when an object has uniform motion, it moves with uniform velocity. Sir, but
Yes.
it's not mandatory that the body will be moving with uniform velocity. For example, if there is a traffic jam, so and then in the next hour the road is free, there is no traffic jam.
If there is a traffic jam, if you're driving through the traffic jam, it is quite obvious here. The velocity will change. You will apply the brake, you will apply the clutch, you will accelerate as you get the way, you will accelerate the vehicle. And as you somebody found in on your path ahead, you will apply the brake. The motion is not uniform. Okay, the motion is not uniform in that case. So for the uniform motion, equal distance should be covered in equal time interval. Okay, so what is the identity of a uniform motion? The object moves with the same velocity. The object moves with the same velocity. That is the magnitude here in the beginning, 20 meter per second. It was the same throughout the motion. The magnitude was fixed, as I mentioned here. Is it clear?
Yes, sir.
Okay, so how to represent this type of motion? This type of motion is represented by a straight line in the velocity time graph. So this straight line represents what? The uniform velocity. This means the uniform velocity, or it
We
is
can't
called
be
the,
too sure that if there is uniform motion the body is moving with uniform velocity, right?
yes, yes. Velocity is constant, constant or uniform. So this shows the uniform velocity. Now suppose that there is a time interval that is time 1 second, time 2 second, time 3 second, time 4 second, and the time 5th second. So if somebody will ask from you, what is the distance covered in the time interval? This is actually from this question. The distance, or we can say the displacement. Okay, distance or displacement. Here it should be displacement. The displacement covered in the time interval 2 to 3 seconds. So what is the distance displacement covered between 2 and 3 seconds? So it is quite easy to represent the displacement. So for that, what we will do, we will draw a line which is perpendicular on this graph. So we will put at 2 seconds. Time is changing. It is 0, it is 1, it is 2. So we will put it at 2 seconds and we will make another line and we will put it at the 3 seconds. Now student, this rectangle having this time interval of 1 second means 3 minus 2, 1 second, and the magnitude of the velocity is v second. This represents the displacement. This represents the displacement of the motion. So this is the displacement. The shaded region represents what? The displacement covered by the object with uniform velocity between the time interval of 2 to 3 seconds. Okay, this is the displacement. So it is quite simple to represent by this shaded region. Now, if somebody will ask the calculation, then we will write displacement is the area under the VT graph in time interval of 2 to 3 seconds. So this is the time interval of 2 to 3 seconds. This is the area between the time 2 to 3 seconds. So this is the time interval, required time interval. So it is quite easy. This is from here to here, it is T having magnitude T, and this having the magnitude V. So it is a rectangular, means length into breadth, length into width. So length is V into T. This is the displacement, this meter. I think it is clear to all of you.
Yes, sir.
Is
Yes,
it
sir.
clear? Okay, very good. So let's move to the next page. 1 minute. Abhineet, Abhineet, is it clear to you, Abhineet?
Yes, sure.
Okay. Abhineet, if you have any doubt, you can ask during the class, okay? I will explain it with the suitable example. So, okay, students, now we will do some numerical problem from this same type of problem. Suppose that a body is moving with the uniform velocity, and this graph represents the VT graph. The time is mentioned along the x-axis and the velocity along the y-axis. This is the origin. Now, students, suppose that an object started from some position and ended at the another position, and the velocity with which the object started was 20 meter per second. Okay, and the time taken by the object uh, to reach from position A to position B was, when we begin to observe the motion, the time was, the time was 3 p.m. and when the motion was ended, this is the initial time and this is the final time. Then the time was 3.15 p.m. 3:15 p.m. quarter past 3 p.m. Okay, the motion began at 3 p.m. and the motion ended at quarter past 3 p.m. So what was the velocity? Velocity was fixed. So velocity was fixed, that is 20 meter only throughout the entire motion when the body moves. So now we have to calculate this distance, this displacement, the magnitude of this displacement. So I think the input is understandable. You got the problem? Have you
Yes,
understand the
sir.
problem? Oh, very good. So we have to calculate the distance. हमें खाली distance निकालना है, distance निकालना है. So we will plot the graph. So what we see, the key point is that the velocity is 20 meter per second, means velocity is constant. So for the constant velocity, just put a straight line. This is the constant velocity. So we will write here the magnitude of the velocity, that is v is equal to 20 meter per second as mentioned in the problem. Now we will plot the time along the x-axis, and this is, suppose that it is 1 p.m., it is 2 p.m., it is 3 p.m., it is 4 p.m., and quarter to this. Suppose that this is 3.15 p.m. This is the required time interval in which we have to calculate. This is the time interval in which we will calculate our displacement. So what we'll do simply, who will tell me now what is the next step? Who will tell me? Piyush, can you tell
Sir,
me the next step? Yes, yes, tell.
we draw perpendicular from the 315 mark, connecting them, and then we find the area under it.
Very good, Kanisha. Yes, we will draw the perpendiculars from 3 to 315. This is 315. Now, this is the required displacement in this problem. This is the required displacement. So we will represent this by, this is the required displacement. Okay, so amount the constant velocity is there, and this is a time interval. So we will calculate our displacement. So second point, displacement, for the displacement, the area of, naming it as A, B, C, and D, area of rectangle ABCD. So length into breadth. Length is, suppose that it is velocity, and the breadth is the time interval. Time interval is t2 minus t1. So v, time interval t2 is 3.15 and it was 3 p.m. The magnitude of velocity was 20 and the time difference from here is 15 seconds. So it is 300 meter. This representing 300 meter.
Sir, why is it 20 times 50? Oh, never mind.
Okay, because the velocity 20 times 15
No, but we will
minutes.
convert 15 minutes into seconds
It
because
will convert.
so we
Yes,
will.
yes. It's minute. I didn't convert it. Divide it with the 60. I forgot that. Divide it with the 60.
Also, we will multiply it, no? Because we're converting.
Multiply. Yes, yes. We will multiply. We are multiplying here by 60 to convert the smaller unit into bigger unit. We divide, and the bigger unit into the smaller unit we multiply. So multiply this here.
So
So
1,800.
yes, 1000,
Sorry, sir. No, 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 sir. Wait a minute. I did a mistake.
1800,
18.
1800 na? Or
Yes.
18,000, uh, more than that.
So wait a minute. No, sir. It's 18,000.
Yes, 18,000.
18,000. Yes,
Yes.
18,000.
Okay. So note it down, students. If you have any doubt, any one of you, please make it clear right now. Abhineet, is it clear? Abhineet,
Yes, sir.
okay. So it was for the uniform motion. Now, if the motion is non-uniform, let's move to the next page. Velocity time graph for non-uniform motion, or we can say that velocity time graph for uniformly accelerated motion. Velocity time graph for uniformly accelerated motion. Uniformly accelerated motion means, let me explain it first with the problem. Suppose that this is the motion represented by the initial and the final position of the object. Now students, velocity changes. The velocity initial was u and the final was v. A is the initial point. This is the final point. This is the time t naught. This is called initial time. And this is the final time. This is the time interval. Now, there is an acceleration. And this acceleration is fixed. This acceleration is constant. Suppose that the acceleration is 2 meter per second square. It means the velocity of the object increases 2 meter every second. So I can say that when the time was t naught, the velocity was u. When the time become t1, the velocity become 2 plus u plus 2. When the time was t2, the velocity become u plus 2 plus 2. When the time become 3, the velocity become u plus 2 plus 2 plus 2. So increasing every second by 2 units. Okay, so by 2 meter, the magnitude of the velocity increasing by 2 meter per second at every second. So this is called uniformly accelerated motion. This motion is called uniformly accelerated motion. This is called uniformly accelerated motion. So let me explain another type of motion. Suppose that there is another type of motion, and this is the initial and this is the final of the object. Now the object started with initial velocity u and ended with final velocity similarly as it was in this case. This is initial position, final position, and this is t0, time initial, but the acceleration is not constant as it was constant in this case because having fixed value of 2 meter. So it is called constant or the uniform acceleration. This is called uniform acceleration. Here the acceleration is not uniform, so it may increase sometime 1, sometime 2, sometime 3. So we do not know what is exactly the rate of change in acceleration. So we will say it as the uniform acceleration, non-uniform acceleration. This is called non-uniform acceleration. Non-uniform acceleration. And this type of motion, for this type of motion, the velocity the velocity of the object at time t naught was u. So we should not put the equal mark here. So I should remove this one. So 1 minute. This is t naught, comma should be there, t2 and t3. Here, similarly here. At t naught, the velocity was u. Suppose that when the time become 1 second, velocity increased by 2 meter. Suppose that when the time was 3 seconds, the velocity increased by 10 meter. When the time was, suppose that when the time was n-second, the velocity increased by 20 meter. So it is not fixed. The rate of change of the velocity is not fixed. This is called non-uniform acceleration. So we dealt with two kinds of acceleration in this portion. This is the non-uniform one, and this is the uniform one. Now we will represent this by the graph. We are dealing with the uniform accelerated motion. So we will make the graph of uniform acceleration only at this point of time. So suppose that once again, we are having two axes, one along the vertical direction and the other along the horizontal one. So we will represent it by time axis and the velocity axis. Now the velocity is changing uniformly. So for the change, uniform change, suppose that the object started from here and the initial velocity was u, and the velocity changes, and it was started from u and become v at the final point. So we will represent it by this, a sloped straight line, a sloped straight line. This is a sloped straight line. Okay, so as it is visible, as it is quite visible in the graphs, we will draw two perpendiculars. So one on the time axis and the another on the velocity axis. Now students, the perpendicular on the time axis represents the time interval. It is the time interval that is represented by t, and along the this velocity axis, this is the magnitude of this final velocity. So this is the final velocity. It means from top to bottom, it is the final velocity, and from left to this point, it is the time interval. So we will represent it in terms of a, b, and it is 0. And now I'll teach you one more thing. So we are drawing some more perpendiculars to form the triangles. 1 minute. So I draw one more perpendicular from the initial velocity to the line AB, which forms a triangle. Triangle A and P. From triangle A and P, it's a right angle triangle, students, and P and BO, it's a rectangle. So now what is the slope? If I say the slope, I already taught you about the slope. This is the theta. So it is represented by this line, velocity time graph of uniformly accelerated motion, straight line inclined to the time axis. So the straight line, I'm writing here, the velocity time graph is so the velocity time graph for uniformly accelerated motion is again straight line which is inclined at time axis. Inclined means having a theta with respect to x-axis. This is line parallel to this time axis. So we can say that it is the inclination with the time axis. Okay. So this is the graph represented by this uniformly accelerated motion. Now note one thing here. The slope of velocity time graph represents velocity acceleration. Represents acceleration. The slope of velocity time graph represents acceleration. So we will write slope. Usually we denote the slope by letter M, and slope is tan theta. So all of you, I think, aware with the tan theta. Tan theta is perpendicular upon base. So slope is what? The slope of velocity time graph represent what? Acceleration. So I am writing this slope as A. It is acceleration, and the perpendicular is Pn. In the triangle, it is Pn, and the base is, sorry, it is An. It is An, and the base is Pn. So acceleration, what is the value of this An? The value of this length An. So it is u. The initial velocity from here to here, it is u. So it is same here. It is u. So we will subtract u from the v. We will get the length of An. Then we will write here as v minus u. This is the length of this perpendicular, and this is the time axis having magnitude t. It is same here. From here to here, it is also t. So we will write v minus u by t. If you cross multiplied it, you will find v minus u is equal to at. We will transfer u to the other side. You will finally get the first equation of motion by using this graphical method. This is velocity time relation. As we just derived in by the calculus method, now this is the graphical method to prove the first equation of motion. I think it is clear to all of you. If you have any doubt, you can ask. I didn't hear. No doubt, sir. At least you should reply. Yeah.
No doubt, sir.
No doubt, sir. Sorry, I was just like reading the work.
Okay, okay. So please write it down fastly. Write it down.
Noted, sir.
Noted, sir.
Okay. Let the Abhinit note it down. Abhinit, are you noting?
So done.
Very good. Okay. So this is the first equation of motion. Now from this very graph, from this same graph, we will calculate the area. We will calculate this area, which is parted in two segments. One is representing the triangle, area of triangle, and the other one is this rectangle. So from the same figure, this is the area of rectangle, and the area under the triangle. This is the area of triangle. So there are two areas under this curve, AP. So what we learned in the previous page, that was the key. The area under the VT curve represent what? The distance or displacement. This was the area under the VT curve represents the displacement. We will use this property and we will calculate the second equation of motion from the same graph. I think you have already draw the graph on your notebook. Use this and we will calculate the next equation. Now, for S is equal to UT plus half AT square. So as we know, the area under velocity time graph represents displacement. So area under curve PA. Our curve is represented by this P to A. And this is the whole area. This is the whole area under this curve. So this is the whole area. We are going to calculate it. The area under the PT curve is first part, the area of triangle AP, and what was the name of other point? AP and N.
And
Yes, area on the APN plus the area of rectangle, naming it POBN. You can name it according to your convenience. POBN. So now this area represents what? The displacement, and the area of triangle is half base into height plus the area of rectangle is the length into breadth, means side PN into PO. PN into PO, PN into PO, and the base of the triangle is PN. I think it is PN. The base is PN, the height is AN. PN into AN plus PN into PO. Put the values from the same graph. PN is T. 1 minute, let me check. PN, yes, it is T, and PO is U. And PO, oh, okay. 1 minute. So half PN is T and VN is V minus U, plus PN again T and UN is U. So it is UT from this side plus half V minus U into T. So in the first equation, we calculated V is equal to U plus AT. What is the value of U, V minus U? It is 80. V minus U equals to 80. We will put here 80, then we will have the value as UT plus half 1T, it is become 80, AT, and the 1T was from here. So it is S is equal to UT plus half AT square. This is the second equation of kinematic motion. The second equation of motion. This is called displacement time relation. This is called displacement time relation. I think it seems easy to you to understand now. I think
Yes, sir.
actually it's quite easy.
Yes, sir.
Sir, I think we studied this in ninth grade also.
Yes, it was in the ninth standard. But you are going to face the difficult problems in 11th, not like the ninth ones. Please note it down and let me know.
Noted, sir.
Noted, sir. Noted.
Abhineet, are you noting? Done. Okay. Students, if you are, if some point is not clear in the derivation or in the concept while I'm teaching, please feel free to ask. I'm here to teach you, okay? And ask at the same moment you are having the doubt. So we have calculated the second equation. Now we will calculate the third equation from the same figure, from the same graph. The velocity time graph. Suppose that the object started from here and it was in motion till here. And we will represent this by the velocities as it is the initial velocity. If you draw the perpendicular on the velocity axis, this is the velocity, this is the magnitude of final velocity. If you draw perpendicular on the time axis, it will cut at time t. This is time t. And the area under this curve, we are naming it as A, B, O, and C. A, B, O, C is a curve which is the trapezium, This is also a velocity time curve. So now we are calculating the area under velocity time graph, the area of trapezium A, B, O, C, A. A, B, O, C, A. Now I'm redrawing this trapezium and I'm bringing out and rotating it the clockwise system. So area of trapezium is this. Let me change the color. There are two bases. One is bigger and the other is smaller. And there is a height. This is height. Suppose that two sides are parallel and two sides are not parallel. So this is the same trapezium. I redraw it. So suppose that this is O. So corresponding position of O is here. This is C, point C. This is point C. It is A. It is A. And it is B. And it is B. So it is our trapezium. What is the height of the trapezium? The height is this, which is exactly equal to this. Now Now measurement are OB having magnitude T. OB is equivalent to T and OB equal to this ABO. It was C actually. It was C. So C, we draw the perpendicular in this manner. CN, it is CN. So OB and CN are equal. It is T is also having the same magnitude Q. OC having this magnitude U. So this is also same U. And AB having bigger magnitude of the velocity V. So AB, the bigger magnitude of velocity V. So we redraw this trapezium from the curve. Now this velocity time graph represents what? The same displacement. The area of trapezium is half into sum of bases into height. So half sum of bases means the parallel sides. The first side is OC, the other parallel side is AB into the height. Height you can take OB or CN. I'm taking here OB. So it will be half. The value of OC is U, the value of AB is V, and the value of OB is T. So finally, it is half V plus U into T. Now from our first equation, it was V is equal to U plus AT. So we will remove this time. So it will be V minus U is equal to T. V minus U upon A is equal to T. This is the value of T. We are substituting this T with its value. So it will be half V plus U into substituting value of T, that is V minus U by A. Now we will send 2 and A to the other side in multiplication. It will be 2AS, and here it is V plus U into V minus U. Now it will be 2AS is equal to, applying the formula, A plus B into A minus B means A square minus B square, or we can write it changing the sides as 2AS means V square is equal to U square plus 2AS. So student, this is the third equation of your kinematic motion. If you have any doubt, you can ask, make it clear right now.
No doubt, sir.
Okay.
Okay, very good, student. Please note it down. It was the last concept of today's class. Please note it down. The shaded area represents the displacement again. Please, students, let me know after noting it down.
Sir, I've noted it down.
Okay, Kanisha.
Yes, sir.
Piyush, have you noted down?
Yes.
Okay. Abhineet, have you noted down?
Yes, sir. Done.
Okay, student. Bye for now. We'll meet in the next class. Okay, good night to all of you.
Thank you, sir. Good
Thank you,
night.
sir. Good night.
Good night. Night.